Alright, so I'm going to show you how to factor some trinomials, and just know that my family's in the background and the TV's on, so you might be hearing things. So here's our first trinomial, and there's my mom talking in the background. So anyway, here I have trinomial, and I'm going to show you how to factor using the distributive property backwards. So first off, you'll always think about what times what is going to equal this last term of 48. So you'll want to think of factors that give you 48. And then, with those factors, which ones are going to add to give you this number 14x. So, for example, 48, right off the top of my head, I think of 6 times 8 is 48. And then what I do from there is say, well, does 6 plus 8 give me that 14? Because if it does, those are the factors I want to use. In this case, they do. So I don't have to think of another factors of 48, like 1 times 48. 1 times 48 does equal 48, but 1 plus 48 will not give me 14. So I found it right away, the special factors. So now I'm going to use those factors. So I'm going to take those factors and I'm going to split up this middle term using these special factors. So I'm going to go x squared, I'm just rewriting it, x squared plus 6x plus 8x plus 48. So I just rewrote that trinomial by breaking up the 14x into those special factors. And it doesn't matter which way I did it. I could have done 8x plus 6x. It'll work out either way. Then from there, I'm going to factor by grouping. So I'm going to look at the first two terms, and I'm going to take out the greatest common factor out of both those. In this case, they have an x in common, and that's it. So when I take out the x, I'm going to see what I have left. In the first term, if I take out an x, I'll have an x left over. I'm going to bring down the plus sign, and then in the second term, if I take out an x, I'm left with that coefficient of 6. So I've taken out the factor of x, and I was left with the quantity of x plus 6. Now I'm going to go on to these next two terms. I'm going to bring down the plus sign, and now I'm going to take out the GCF of these two terms. Now, I will not take out an x in this case, because there is no x in the 48. So I'm going to look at coefficient 8, and I'm going to look at the constant term of 48, and say they both have a factor of 8 I can take out, and guess what is left over? I'm left over with x plus, not 48 anymore, because if I take out a factor of 8, I am left with 6. And right there is where I have a moment of joy, because if you notice, this quantity is the same as this quantity, which is really cool, because now, if I erase all this, now I'm to my last step of factoring, because now I have a factor that is common in both of these two terms. Let me show you. Here's the first term now, separated by the addition sign with the second term. And this first term and this second term have one thing in common and one factor in common, and that is x, the quantity x plus 6. So now if I factor that out and I take that out, what do I have left over? I have this x, the plus sign, and the 8. And there I have it in factored form. X plus the quantity x plus 6 times the quantity x plus 8. So let's try another one. Let's say I have x squared minus 14x plus 45. So now again, I'm going to go to the factors. I want to find those special factors. So now I look at 45, and I'm thinking, what times what is 45? Right off the top of my head, I think of 9 times 5. And guess what? Oh my gosh, that actually gives me 14. So now what you have to keep in mind is, in this case, unlike the last case, this one is not just a 14x, it's a minus 14x, which is really the same thing as plus negative 14x. So when I break this up, x squared, I can bring down that plus, it's not going to be a positive number. It's going to be a negative 9x plus a negative 5x. Because when I add a negative 9 and a negative 5, I'll be back to a negative 14. If you do not like putting the plus negative, then you could just put a minus. And I mean, that'll be nicer. But this actually works out good when you start and finish the factoring. So now I have my special factors. I broke them up. Now I'm going to factor by grouping. So I'm going to look at my first two terms, and I'm going to take out what is common, the greatest common factor. In this case, what do you think it is? It is x. And what do I have left over? I have x plus a negative 9. And in this case, again, like I said earlier, I'm just going to go ahead and put a plus negative is the same thing as minus. Now I'm going to bring down the plus, and I'm going to look at these two terms and say what is common amongst them both. Not only common, but the greatest common factor. In this case, it is 5. Now the question is whether I want to take out a negative 5 or a positive 5. Well, if I took out a positive 5, look what happens. What am I left with? Would I be left with that negative and the x, which is not good, because if you look back over here, I just have a positive x, which means that I should be taking out a negative 5, so that what am I left over with? Just that x. Now, if I take out a negative 5 from here, you have to think, negative 5 times what will get me back to a positive 45? Negative 5 times a negative 9. And like I said, you could put a plus negative, or you could just put minus 9. And this is your moment of joy, because look at there, you have the same factor, x minus 9, which is what you want, because now you're in the final step. And I'm able to say I have the common factor of x minus 9. I factor that out of those two terms, and I'm left with x plus negative 5. Or in simpler terms, x minus 5. Okay, let's do one more. And this time I want to show you this because you have all multiple choice questions. So if you didn't want to do all those steps, you could just use the distributive property and just check which one is going to work. So I'm going to show you that. So if I have a trinomial, x squared minus 5x minus 14, and here are my answer choices. X minus x plus 2, x plus 7. So here's the first answer choice. Let's just do two answer choices right now. X plus 2 and x minus 7. Okay, when I look at this first answer choice, I right away in my mind know that it's not going to be the right answer. And it's not because I already know what the answer is. It's because when I look at this positive 2 and this positive 7, when I use the distributive property to multiply this out, I'm going to end up multiplying the 2 times the 7, which will give me this final term. And 2 times 7 is positive 14. And in this one, we don't have a positive 14, we have a negative 14. So right off the bat, I know this one is not going to work. If I go to answer choice B, will I get a positive 14? Well, I have a positive 2 and a negative 7. So that will give me negative 14. So I'm like, oh, okay, this one might be it. Now what I need to check is if that positive 2, if I add a positive 2 to a negative 7, will that give me this coefficient of negative 5? And is 2 plus a negative 7 equal to negative 5? Yes, it is. So that's kind of my shortcut in my brain that I do. So I know this one is going to work. I know answer choice B is going to work. But if you really want to, I could say that I need to multiply x, this x, by this quantity, x minus 7. And I need to multiply 2 by the quantity, x minus 7. So when I do that, I'm going to get, I'm running out of room, so I'm just going to do it above it. x squared minus 7x plus 2x minus 14. And then the final step would be to put the two middle terms together, and I would end up with x squared minus 5x minus 14, which is what I have up here. So let me know if this helped or if you needed a couple more examples. Okay, sorry it was so long. Bye.